The James Webb Space Telescope is upsetting the apple cart, forcing us to reconsider what we thought we knew about the universe and perhaps even rewrite the textbooks on its beginnings. For decades, Pluto has remained one of the most mysterious members of our solar system. Since its discovery in 1930, astronomers and space enthusiasts alike have wondered what lies on its icy surface, what secrets hide beneath its frozen crust, and what its strange orbit reveals about the outer reaches of our cosmic neighborhood. In 2015, NASA's New Horizons spacecraft gave us our first close-up images of Pluto and the breathtaking views of ice mountains, vast plains, and even a thin atmosphere were unforgettable. Yet, New Horizons was only a flyby. Came, snapped pictures, and moved on, leaving us wanting more for nearly a decade. Now, the James Webb Space Telescope has delivered something extraordinary. With its unparalleled infrared capabilities, Webb has captured an image of Pluto unlike anything seen before. Not just clearer, but deeper, with every pixel alive with detail, textures, and patterns invisible to any previous telescope. If New Horizons gave us a postcard from Pluto, Webb has handed us a full-length high-definition documentary. Unlike a quick pass, Webb observes, studies, and peels back the layers of the cosmos. Its golden mirrors have given us an image that feels less like looking through a telescope and more like standing in orbit around the dwarf planet itself. But the story goes beyond a single picture. It's about what that picture represents. For years, Pluto has symbolized the limits of human curiosity. Distant, cold, and isolated, a tinied at the solar system's edge. Yet with Webb, that dot transforms into a world. Surface variations are clearer than ever. From regions of nitrogen ice to shadowed craters and subtle color changes that hint at complex chemistry. And perhaps most fascinating of all, Webb's infrared eyes reveal more than beauty. They uncover temperature differences, chemical fingerprints, and a deeper story about a world far stranger than we ever imagined. The way Pluto interacts with its thin, tenuous atmosphere transforms what might seem like a frozen, silent world into one alive with invisible activity, almost as if a frozen painting suddenly shifted into a living, breathing landscape. The truth is, we've only just begun scratching the surface of what the James Webb Space Telescope can reveal about Pluto. This first image is only the opening act. And as more data pours in, astronomers believe we may uncover secrets about Pluto's geology, its seasonal changes, and perhaps even evidence of a hidden ocean beneath its icy shell. The next time you look up at the night sky and think about the edge of our solar system, remember that thanks to Webb, that distant edge has never felt closer. But before diving into what Webb has actually uncovered, it's worth rewinding the clock. Because to understand why this new image is such a groundbreaking milestone, we need to revisit Pluto's complicated past. A story steeped in discovery, controversy, and endless fascination. When Clyde Tombaugh first spotted Pluto in 1930 through a telescope at LOL Observatory in Arizona, the world was captivated. Here was a new planet at the far edge of the solar system, a frozen sentinel orbiting in the dark. For decades, Pluto held a special place in astronomy as the little planet that could. Textbooks were rewritten. School children memorized its name as the ninth planet. And Pluto became a symbol of discovery itself. But its story was never simple. Astronomers soon realized Pluto was far smaller than expected, barely 2/3 the size of Earth's moon, measuring only about 1,500 m across. That raised difficult questions. How could something so tiny be considered a planet on the same level as giants like Jupiter or Saturn? The debate came to a head in 2006 when the International Astronomical Union redefined what it means to be a planet. Their rules were strict. Planet must orbit the sun, be spherical in shape. And here was the deal breaker: clear its orbit of other debris. Pluto passed the first two tests, but failed the third. As its orbit overlaps with countless icy bodies in the Kuiper Belt, a vast region beyond Neptune. And just like that, Pluto was demoted to a dwarf planet. The world reacted with shock. Headlines blared, teachers scrambled, and millions felt an odd sadness, as though a beloved friend had been unfairly stripped of its title. Even today, many refuse to accept the demotion, insisting Pluto will always be the ninth planet. Yet here's the twist. Losing planetary status didn't make Pluto less fascinating. If anything, it fueled an even greater determination to study it. A determination that eventually led to NASA's New Horizons mission. Launched in 2006, the very year Pluto was reclassified, NASA's New Horizons spacecraft took nearly a decade to reach its icy destination. But when it finally arrived in 2015, the world was once again in awe. Those first close-up images revealed towering ice mountains, vast heart-shaped plains, and a surprisingly active surface for such a small, distant world. Pluto was no longer just a dead rock drifting through the void. It was dynamic, complex, and alive with geological activity. The controversy over its planetary status only added to the fascination, transforming Pluto into more than a planet or dwarf planet. It became a symbol of curiosity, resilience, and our ever-changing understanding of the universe. Science, after all, is not static. It evolves, it questions, and it redefines itself. Pluto's reclassification was a reminder that even the truths we take for granted can shift under the weight of new discoveries. That is why the James Webb Space Telescope's latest image feels so powerful. It's not just about seeing Pluto more clearly. It's about continuing a story nearly a century in the making. From its discovery to its demotion, Pluto has been at the center of debates, emotions, and groundbreaking missions, and Webb has now added a breathtaking new chapter. When the telescope's 21-foot golden mirror turned toward Pluto, the result was astonishing. For the first time, we saw the dwarf planet with a clarity that rivaled and in some ways even surpassed the New Horizons flyby. But Webb's achievement wasn't limited to sharper pictures. Its advanced infrared instruments revealed aspects of Pluto invisible to telescopes that see only invisible light. At first glance, the new image appeared almost surreal. Pluto glowing against the blackness of space with crisp edges, rich contrasts, and surface details that had eluded astronomers for decades. Gone were the blurry, grainy shapes of earlier telescope photos. In their place appeared fine distinctions between icy plains, rugged mountains, and mysterious shadowed regions near the poles. Even the famous heart-shaped tombayo, which captured the world's imagination in 2015, emerged, with new textures and layers of subtlety. Yet, the true magic came from Webb's ability to study Pluto in the infrared. Unlike New Horizons, which could only snap images as it sped by, Webb lingers, observing how Pluto reflects and absorbs heat. This has allowed scientists to map its surface composition in exquisite detail. In Webb's latest image, differences in nitrogen ice, methane ice, and complex organic molecules leap out with stunning clarity. Regions once thought uniform now appear alive with variation, like alien deserts, seas, and continents carved from frozen chemistry. Even more remarkable is what Webb detected in Pluto's thin, fragile atmosphere. While New Horizons had hinted at hazes, Webb went further, picking up faint signatures of hydrocarbons and even subtle seasonal changes. Imagine that. A world 3 billion miles from the sun, cold enough to freeze solid, yet still exhaling gases and interacting with its environment. It is as though Pluto is whispering its secrets across the vacuum of space. And for the first time, Webb is sensitive enough to listen. Perhaps most jaw-dropping of all, the new data suggests Pluto is far more dynamic than we once believed. Subtle changes in brightness and texture hint at shifting ice, migrating frost patterns, and possibly even geological processes stirring beneath the surface of this distant, enigmatic world. Some scientists speculate that Pluto may still harbor a subsurface ocean, locked beneath miles of ice and slowly reshaping its surface over time. For space enthusiasts, these revelations are exhilarating. For scientists, they spark new questions. How active is Pluto really? Could hidden oceans or chemical reactions make it more than just a frozen ball of ice? And what might these clues reveal about other icy worlds such as Triton or Europa? Webb's crystal-clear view of Pluto is more than just an upgrade in image quality. It's a reminder that even tiny distant worlds are filled with complexity and wonder. Pluto is no longer a feint on the outskirts of the solar system, but a world with character, history, and mysteries that could transform our understanding of planetary science. Yet, Webb's discoveries go beyond breathtaking imagery. Its data has uncovered surprising details that challenge long-held assumptions about Pluto's environment. Findings that are beginning to rewrite what we thought we knew about the icy dwarf planet while hinting at possibilities that could reshape how we see the entire solar system. If the scrambled 12th frame of Cassini's final transmission was the lock, then the question haunting scientists was simple. Where was the key? Some dismissed the anomaly as meaningless noise, the natural result of Cassini systems burning up in Saturn's atmosphere. But others weren't convinced. The data didn't behave like static. It carried repeating patterns, faint but deliberate, that collapsed whenever researchers tried to force them open. When quantum AI pushed deeper into the corrupted frame, strange feedback began to ripple through the system. Hardware that had flawlessly processed terabytes of raw space data suddenly faltered. Processors overheated, memory caches filled with recursive loops, and programs spiraled endlessly. It was as if the missing image wasn't simply scrambled, but actively resisting decryption. That raised a chilling possibility. The image wasn't meant for us. Or worse, it was meant only for those with the right cipher, something humanity has yet to discover. Then came the silence. Every attempt to probe the corrupted frame triggered mysterious outages. Terminals dimmed, fans stopped, laboratories fell into an eerie hush before power flickered back as though nothing had happened. Engineers swore such behavior was impossible. Yet it happened again and again. The 12th frame had become more than data. It was treated like a forbidden relic, locked away in isolated servers and studied only in brief intervals. Strangely, the longer it was examined, the stronger the hush effect became. Some whispered that Cassini's last gift wasn't an image at all, but a message, one sealed in silence. A handful of researchers went further, suggesting the frame wasn't corrupted by accident, but encrypted on purpose. They proposed that what Cassini captured in its final moment was so extraordinary, so dangerous that the universe, or something within it, chose to lock it away. What could be so powerful that it had to remain hidden? A shape, a structure, a symbol carved against Saturn's clouds that suggested design rather than chance. And if design, then who or what was the designer? No one knows. The 12th frame remains sealed, a riddle without a key, and the silence surrounding it has become louder than the image itself. Somewhere in that missing fragment